Gambling with four dice, what is the probability of getting an even sum?
Oh, wait, 2, 4, 6, 8. Oh, I can't work that either. Okay,
Listen, should I discuss?
okay. Yeah, sure, sure, sure.
Gambling with four dice, what is the probability of getting even sum? So basically, we have four dice.
Mm.
So first of all, can you tell me how many total number of sample space we will have? Total number of sample space.
12. Oh, like
Number of
that.
elements in sample space. How many sample space number of elements in my sample space?
Sample space essentially means how many outcomes there are, right?
Yeah, all possible outcomes. How many possible outcomes will I will use?
12 possible outcomes.
You sure?
I mean, oh, no, no, no,
No.
sorry. Gambling with four dice.
Yeah.
Four dice.
Okay,
I
please
mean, the
see.
way. Okay, okay, yeah.
Now suppose, wait, link your knowledge, you know this. Suppose I have one dice, right?
Mm.
How many number of sample space I will have? Six. And they
Yes.
are one, two, three, four, five, and six. Now suppose I have rolled two dice. How many
Mm.
sample space I will have? How many members it will have?
If you roll two dice, you'll have 2 through 12. 2 is the smallest, 12 is the max.
No,
Is it
no,
correct?
no, no, no. See, the sample space may have like this one, two,
Oh,
1, 3. These are the sample space, right? I am not uh,
mm,
finding any probability. We are writing just the sample space. What should be
I
the
see.
outcomes possible? So it should be 1, 6. Similarly, 2, 1, 2, 2, 2,
Mm,
3, and like two,
mm,
6, isn't it? So
uh-huh.
in this way, if you write how many elements it will have. So number of elements in your sample space. How many members I will have if I write in this manner?
I see. That's the question. Okay. So then it will just be, oh, okay, okay. Now I get it. So this one, it will be
Should be,
36.
yes, 6 into 6, that's the 36. And this is
Yes.
again with the help of principle of
Multiplying on
counting.
only.
Yeah, principle of, see, this first place can be filled in six ways. The first dice can fill it in six ways. Similarly,
Six
this
ways.
second space can be filled in six ways. My task will be completed when I do both the rolling of both the dice. So it should get multiplied and it should be 36, isn't it? So
Yes, yes, yes.
similarly, here we have to roll four dice. So how many
Mm,
sample space I will have total? It should be 6 into 6 into 6 into
yes,
6. That should be equals to
yes.
6 raised to power 4.
Correct.
Now
Yes.
we have to find how many cases, in how many cases we will have even sum. In how many,
Even someone. Okay.
yeah. So now we have to find number of events or number of
Mm,
favorable events. Okay, for
okay.
that, let's see. In one dice, we have some even numbers and we have
Okay.
some odd numbers. In
Mm,
even numbers, we have 2, 4, and 6. And odd number,
yes.
we have 1, 3, and 5. We have to find in the sum of four numbers should be an even. So please find what are the possibility to get an even number. So first possibility is if we have even, and even, isn't it? The sum will be even,
Yes. Mm-hmm.
correct? The second possibility we will have odd, correct? Let's see. If you
Yes.
add odd, you will get an even. The next
Yes.
is even, and then odd,
Yes.
right? See, you may say odd, even. We will count it in one step, right?
Yes.
Any other possible combination, if you can think, please let me know.
Oh.
Either you may have four even numbers, the sum will be even. You will have four odd numbers, you will have even sum. You will have two even, it means again this is the even and plus this is an even. So even plus even, you will have the even. We cannot have odd number of even or odd number of odd numbers. Are you getting my
I
point?
see.
So only
Yeah.
three possibilities will be there. Now
Mm-hmm.
we have to find how many cases I will have in which belongs to this even. So please see, there are four places I have to fill up. In how many
Mm.
ways this can be filled? This first place can be filled in three ways. How? Because I have
Yes.
the only three possibility of filling as an
Yes.
even number. Similarly,
Mm.
this will have three ways.
Mm.
This will have three ways. This will have three ways. Are you getting this?
Mm.
So I will have total 3 raised to power 4 ways in which all the numbers will be even, isn't it?
Okay. Yeah.
Similarly, the odd one will be also will have the same counting. See, this place can be filled in three ways. Similarly, this
Mm.
can be filled in three ways,
Correct.
this three ways, and this
Correct.
three thrice ways. Okay, so this should be 3 raised to power 4 due to multiplication. Now, this one. Now I want see one more thing. One more thing. Here it should be noted that
Mm.
it's not important that it's not necessary that you should have even, odd. You may have even, odd, even, isn't it? You may have
Yes.
even, odd. You may have odd, even. So all these possibilities I have to consider, isn't it? You may have other possibility also. You may have
Mm.
all other possibility also. So we will try to count all
Mm.
these cases in a single step. So how I can count
Ah.
them? It means I want to find the number of cases in which I want to
Yes.
find number of cases
Mm.
in which I will have two even numbers and two
Mm.
odd numbers. Their arrangement may be anything. They can be arranged in any order. I'm not interested
I
in
see.
their arrangement, right?
Order. Okay.
So, okay. So how we can find it? So, yeah, let's see.
So,
Hmm. So, one more thing. Suppose we have this even, odd. In how many ways they can arrange? Suppose we have to arrange this even, odd. In how many ways they can be arranged? Can you find it? If we
how many
arrange
ways you
it,
can have even ordered essentially?
yeah. So it should be factorial 4 upon factorial 2 into factorial 2. Are you getting this?
Yes.
First, we assume that all are different, so they can be arranged in factorial 4 ways. But since we have the repetition, even, odd, so they should be divided with their repetition number. Do you know this? This kind of calculation?
Ah. Mm. I mean, yeah. No.
Yes or no? No or don't know? Tell me clearly.
Yes, I think I do. I do. I do.
Okay. So, how many cases it should be? So, it should be 4 into 3 into factorial 2 upon factorial
mm,
2 into factorial 2, this factorial 2 will cancel out this 2 and 6. So basically, they can be arranged in six number of ways in which some of them I have written. Correct?
okay, okay, sure.
What is the okay, let us analyze this first case. In how many ways this can be achieved? This E zero, this even, odd, even. See, suppose we have these four places. So this place can be filled in three ways. I want even
Mm,
number here. This place
mm,
can be again filled with the three ways. I want odd number
mm,
here. Here
yes,
also it will have three ways. Here also it will have three ways. So
three
total
ways, yes.
it should have 3 raised to power 4 ways, isn't it? Again.
Okay, yes,
But now I
correct.
will have total six cases here. There are total six such cases. And in
Mm,
all these, you have the same cases that 3 raised to power 4. If you analyze this, 3 ways, 3 ways, 3 ways, 3 ways. So you will have 3 raised to power 4 ways. So how many total ways for this case? So you will have 3 raised to power 4 plus 3 raised to power 4 plus 3 raised to power 4 plus,
mm,
and this will be repeated, this will be added six times because we have total six cases. So it should be 3 into 6 into 3 raised to power 4. Are you getting this?
mm, yeah.
Now,
Okay,
how
now I get
many
it. Yeah.
how many total cases? So n of e, I can write n of e, total number of favorable case. So I have to add this 3 raised to power 4 plus this 3 raised to power 4 plus this
Mm,
6 into 3 raised to power 4. This divided by the total number of sample space, that is 6 raised to power 4. Okay, so let us try to solve this. So 3 raised to power 4 you can take as a common. So you will get 1 plus 1 plus 6 upon 6 raised to power 4. So
sure.
you will have 3 raised to power 4 into 1 and 2, 8 into. This 6 raised to power 4 can be written 2 into 3 raised to power 4, isn't it? So it should be 3 raised to
Yes.
power 4 into 2 raised to power 3 upon this should be 2 raised to power 4 into 3 raised to power 4. The 3 over 4, 3 will cancel out. So you are getting 1 over 2.
Mm,
So the probability should be 1 over 2. Have you understood why I have taken this question? The question is why I have taken. So I have taken this question for our discussion to to introduce to discuss on permutation and combination as well. From this single
mm,
question, I have tried to explain permutation and combination as well because these
I
are
see.
in your syllabus also.
Mm.
Any doubt you can ask?
No, I don't really have much of a doubt. Makes sense.